Hi, good afternoon. This is Mr. Cassidy, and I know lately Teams was having some issues, so I just thought I'd record what we went over in class today, so anybody who needs help with it can review. So I began class with a review of the quiz you took on Monday, 11/16, and on this quiz you had 10 questions, and I'm going to go through how to solve each one. Now, please note that some of the numbers are changed on your individual quiz. However, each idea should be pretty much represented. So if you see what you're supposed to do on the problem, you might be able to track down any numerical mistakes you may have made. Let's jump into it. Problem 1, use intercepts to graph the equation. Well, to do that, I create a little t-chart, and I want to find the y-intercept, which is when x is 0. And then I want to find, well, let me start with that. So x is 0, so that means I'm going to plug in 0 for x and keep y unknown. And once I have that, I can multiply. -3 times 0, well, that's just 0. So all that's left is 2y equals 12. And from there, I would divide by 2 on both of these. And I get the y-intercept is at positive 6. So when x is 0, y is 6. That's my coordinate pair. And the y-intercept is right here on the graph. Next, I want to find the x-intercept. And x-intercept is when the y's feel like zeros. So y is 0. I'm going to go ahead and plug in to my equation 0 for y. And equals 12. And what I need to do is solve for x. So that'll give me the x-intercept. Well, 2 times 0 is 0, so -3x equals 12. And from there, I would divide by -3, divide by -3. Okay, it looks like x is equal to -4. So now that I've got that, I've got my x-intercept, -4, 0. To graph that, I go on the x-axis to -4. And those 2 points are all I need to graph the equation. And that's the line. Right, moving right along. I think that's the last one on this slide. Let's go on to problem 2. Oh, looks like it's not loading. There we go. All right, problem 2. Problem 2 is fairly similar. It's just horizontal and vertical lines, but you sort of graph them like intercepts. So like, remember, vertical is when you have x equal to something. And so in the case of x equals 3, I put a dot where x is 3. That's my x-intercept. And then you just put another dot either above or below that, and that'll create the vertical line at x equals 3. Now, horizontal lines are when y equals something, and you only have one letter. Again, one letter means you can't have any rate of change. You can't have a diagonal line because you have no relationship there. Both of these are just constant. Well, horizontal lines are typically called constant, so y equals -8, any y equals are horizontal. So what do? I go down to 8, or -8, and I would put a dot on the y-axis. That's my y-intercept, and then you just put one other dot for it to graph online, and that'll create a nice horizontal line for you, like that. Okay, next problem. Find the slope in the y-intercept. Now, again, you may have been marked wrong on this. I will go back and adjust scores. The slope is m, so all we need is m, -1/7. That is correct. Now, if you put the x, it'll mark you wrong, but I will change the score. But just know in the future, slope is just the letter m. X stands for whatever input goes into the equation, or any of the coordinate pairs. So m is the only number for slope. Now it's mx plus b. B is for begin. B is the y-intercept, so we just put 2 here. Again, if you put 0, 2, you would be correct, but the computer would mark you wrong. I will fix that. All right. Write an equation of a line with a slope of 3 and a y-intercept of 4.5. Well, here I would do y equals 3x, because 3 is m. y-intercept is 4.5, so I'm going to put plus 4.5. That's it. Write an equation of a line passing through negative 2, comma 3, and 0, 8. Well, in this case, I still need mx plus b. But what I'm missing here is I'm missing m, so I need to find m first. So I'm going to go ahead and find the rate of change, or the slope. Negative 2, comma 3 is one coordinate. The next coordinate is 0, 8. And so I find the rise and the run. That's adding 5 and adding 2. So 5 over 2 is m. So I can fill in that part of the equation. 5 halves x. Now I just need the plus b. Well, we have to analyze our problem. Here we have two different points. And remember, how did the x's feel when the y's intercept? Like zeros. So b is wherever x is 0, which is this coordinate pair. So b is the number 8. 0, 8 is where that dot's going to be on the y-axis. That's our y-intercept of this problem. So I just fill in plus 8 here, and that's my y equals mx plus b for this problem. All right, carrying on to the next slide. All right, so write a linear function f with the values f of 0 equals negative 3 and f of 7 equals 11. The key to this problem is that it's the same as the last problem. It's just written differently. All you have to do is change it to coordinates. 0, negative 3 is the coordinate pair that they have given us. 0 is the input, the x. Negative 3 is the output. And notice that that is also the y-intercept. There's b. All right, the other coordinate they gave us was 7, 11. And so how are we going to solve it? Well, we're going to do mx plus b. First, I'm going to find m. So that is adding 14, and that is adding 7. M is equal to 14 over 7. Now I could simplify that to 2 over 1, or just the number 2. I'm going to go ahead and leave it as 2. 2x is the equation so far. Now, next I need the plus b. Mx plus b is what I'm looking for here. B is going to be negative 3 here, so minus 3. 2x minus 3 is the answer. Write an equation in point-slope form of a line that passes through 4, negative 9, and has a slope of 6. Well, here I'm just filling in the blanks. Our formula is y minus y1 equals m times the quantity x minus x1. And all we need to do is fill in what we know. Well, slope is 6. That's m. So in the blanks here, I would put 6 outside of the parentheses. Next, remember, all coordinate pairs are x's and y's. So x1 is 4, y1 is negative 9. So all we're going to do is fill in this case, negative 9 goes here, and 4 goes here. That fills in point-slope form for this equation. Number 8, continuing on. F of negative 1 equals 8. That gives me a coordinate pair, negative 1, 8, and another coordinate pair, 5, 6. So what do I do here? Well, notice neither of those is the y-intercept. So this problem adds a tiny bit more challenge. We have a few steps to do to solve, and I'm going to use point-slope form. But in order to get mx plus b, that's my goal. Mx plus b is right here. I'm writing that as my goal. I first need my slope. So I'm going to go ahead and do slope over here this time. Negative 1, 8, and 5, 6. Great. So finding the rate of change. 8 changes to 6, so that's minus 2. Negative 1 changes to 5. That is adding 6. M is negative 2 over 6. And if I simplify that, I get a negative 1 over 3. Okay. Now that I have M, I'm going to use point slope form, which you can find in the problem above, and I'm going to pick a coordinate pair. Remember, it doesn't matter which one. You could pick negative 1 comma 8 or 5 comma 6. I prefer to use the one with positive numbers because it's easier. So x1, y1. So let me go ahead and plug that in. So I would get y minus 6 equals, m is, I found that already, negative 1 over 3, times the quantity x minus 5. Now there are two main steps that are going to help you in like all of the next three problems. The two main steps are, let's put in purple here, after you've done point slope form. So step one that we've already done is point slope. First I found slope, then I put it in point slope form, picking one of the coordinate pairs. Step two is going to be to distribute. You want to remove parentheses because we want it in mx plus b format, distribute. Last, what we're going to do is, well, I'll show you that step last. So right now I'm on the distribution step. I'm going to distribute negative 1/3 times both things in parentheses. That would give me y minus 6 equals negative 1/3 x. And negative 1/3 times a minus 5, well, that'll be a positive. Negative times negative is positive. 1 times 5 is 5 over 3. Okay, there's one final step now. I'm going to go ahead and switch to green. My final step is isolate y. Since I want mx plus b, why don't I go ahead and isolate the y value? Well, how do I do that? Well, I have y minus 6, so what if I add 6 to both sides? Now, some of you guys probably got hung up because your problem had fractions here, and that's really just an arithmetic problem that we need to make sure we review. So to add or subtract fractions, what do we do? Well, if I have 5/3 and I want to add the number 6, the whole number 6 over 1 to it, well, I need to put 6 in terms of thirds. So let me multiply the top and bottom by 3 so that I get it where you can multiply anything as long as the top and the bottom are the same. And that would give me 18 over 3. Hey, that actually makes this problem easier. 5/3 plus 18/3. I'm going to combine those and get 23 over 3. So my final answer, 23/3 is the y-intercept. And the rest of the equation is y equals negative 1/3 x plus 23/3. A little bit tight there, but hopefully you get the point. Okay. Remember, to add a fraction, you're going to need to convert a whole number so that it has to an improper fraction that has the same denominator. Then you just add or subtract the numerators. Now, our final two problems are pretty similar. Problem 9 of the quiz is to write a parallel line that passes through a specific point. Well, what did we learn about parallel lines? Parallel lines have the same slope. They rise and run at the same rate. So what do? Well, we need the slope of the old line. That's where I'm going to steal it. Now you can do slope a few different ways. I've shown you can use the coordinate pairs they give you. I personally prefer to just draw it on the grid and find the rise and the run. It's rising 6 and running 3. So my old slope of the old line was 6 over 3, which is the same fraction as 2 over 1, or just the number 2. Next, I want an equation of a line that passes through a specific point. So I've got the slope to keep it parallel, 2 will keep it parallel, and I want it to go through the coordinate 3, 7. Well, that's where I'm going to use point-slope formula. So to do that, I'm going to plug in y minus 7 equals 2 times the quantity x minus 3. There it is. So to do this, I distribute the 2. Now the final two steps, same as the last problem. Step 1, distribute. Step 2, well, I'll get to that when I get to it. First, I distribute the 2, and I get y minus 7 equals 2x minus 6. 2x minus 6. My apologies for the sloppiness. Last, isolate y. I want it to be y equals. So what do I do here? I would add the 7 to both sides. And what I get is y equals 2x plus 1. That's a 7 right here. That's my equation. It's going to be parallel to this line because this line's slope was 2. This line is probably y equals 2x plus 2. And the new line will go through 3, 7 way up here. And it'll be parallel to it just like that. Okay, final problem. The final problem is very similar to the last two. The only difference is they ask us about a perpendicular line. And so our lesson on Thursday, Friday of last week was about perpendicular lines. In this case, a perpendicular line, we take the old slope, and what we're going to do is we're going to flip it and change the sign. That'll make the line completely the opposite in terms of steepness and direction. Change the sign. So let me go ahead and find what's my old slope. Well, here's the line. Down 2 over 1, 2, 3, 4, 5, 6. 2 over 6. Down 2 would be the same as negative 2 over 6. And to simplify that, that's the same as negative 1/3. Now what I need to do is I need the perpendicular slope. So the slope that's perpendicular is going to be in red. That means I flip over the numbers, which is 3 over 1, and I change the sign. It was negative, now it's positive. That's m, or the slope of the perpendicular line. Final steps are going to be to use point-slope form, distribute, and isolate the y. The same 3 steps we've used in the last several problems. Y minus. Now, which point am I going to use? Do I use the ones on the graph? No, these are the points on the old line. They want a line that passes through negative 1, 4. So y minus y1, y minus 4 equals 3 times the quantity x minus negative 1. Well, let me simplify that. Minus a negative should be simplified to x plus 1. Y minus 4 equals x plus 1. Then I'm going to go ahead. Oh, sorry, I lost the 3. Next step, distribute, just like the problems before. 3x plus 3 goes here, equals, y minus 4 is still here. And finally, isolate y by adding 4. I want to move that 4 to the other side. Well, that does it. When I simplify that, I get my answer. Y equals mx 3x plus b, in this case it's plus 7, and that's the equation of the line perpendicular to the original line. It's perpendicular and it goes through a specific point. If I were to graph this, the coordinate pair would be here. 7 is the mx plus b, and it's going down like this and up this direction. And what we see here is it forms a right angle with the original line. That's 90 degrees, a perfect corner pair. So this line is perfectly perpendicular to the original. Well, that covers our quiz review. I thank your minds and your hearts, and I wish you a good math afternoon.